All right. My name is Rishi Singh from Cleveland Clinic in Cleveland, Ohio, and it's a pleasure to welcome you on a Wednesday night to this Ophthalmic Clinical Education Summit. This is the third of the three series we've done now with Zeiss and covering various topics in this field. And there's certainly the website, which you can go back and look at the other programs. But tonight's program actually is with a colleague of mine, Eric Schneider from Tennessee Retina Physicians, who is going to be discussing putting this all together. We've discussed OCT in the last seminar, OCTA in another one prior to this, and you're really just trying to understand how all of this data fits together and how we can analyze this data in clinic in a rapid fashion. And Eric is going to take us through his talk and how he puts this all together. So thank you for all joining. So with that, I'll turn it over to Eric to start the presentation for tonight's program. Here's our agenda for today. So without further ado, I'll turn it over to Eric, and he'll take us through the program.
All right, why don't we launch into the meat of our presentation here on Zeiss Form Review in Retina Workplace. The presentation is entitled Putting It All Together because hopefully, as you'll be able to see during the course of the talk, this is exactly what a high-quality image review platform can do for your practice, at least in terms of retinal imaging. This talk is part of a larger virtual user meeting that Zeiss has been gracious enough to put on over the past several weeks. And hopefully, as part of that experience, you've been able to learn a little bit more about some of the innovative and powerful imaging devices from Zeiss, including the Cirrus 6000 and the Claris 5 and 700. Certainly, these devices provide a lot of opportunities to use this multimodal functionality to explore different aspects of retinal disease, which I think can really help boost the diagnostic utility of your retinal imaging. That's a great aspect of these devices, but one of the downsides is it does end up generating a lot of usable images, whether it's a 12 millimeter HD one-line scan or a 12 by 12 millimeter OCTA study on the Cirrus, or a wide field ICG or fluorescein angiogram on the Claris 700, you end up having to spend a lot of time working through all these images that you've obtained. This can lead to a problem that I've coined image overload. What image overload is a problem that stems from several root causes. I think number one, we're all getting more frequent imaging. Many of our patients see us frequently, even monthly, and receive a retinal image at every visit. Obviously, as we discussed on the previous slide, there's a greater diversity of imaging modalities available to us today, and I think we're all seeing increasingly larger patient volumes. This can lead to one of two problems. Number one, either we engage in these prolonged and inefficient patient encounters in which we spend a large amount of time reviewing images, clicking between different softwares, and typically having our backs to the patient. This is obviously not an efficient way to run a clinical practice. The second alternative is that we engage instead in inadequate image review, in which providers fail to maximize the diagnostic value of the imaging that they've obtained. I think they're both lead to a poor quality clinical care. I think regarding the prolonged and inefficient patient encounters, I think that's particularly worrisome during the COVID-19 era, in which I think high patient throughput and a lower density of patients in clinic is particularly important to help curb the spread of the virus. So I think the challenge for the modern day retina provider then becomes, how do we sensibly analyze our imaging data while still efficiently utilizing our clinic time and still trying to maintain a patient-focused and interactive manner. There have been several solutions to this problem that have been proposed in the past. I think the most traditional approach is to use these paper printouts for each imaging study that's obtained. Manual printing is certainly a slow and tedious process, can be quite expensive due to the consumption of lots of printer ink. And when you review these images, they're quite small and lower resolution, so I think you don't capture the full impact of some of these images. Also, you're unable to interact with these images, right? You can't scroll through an OCT, you can't zoom in on a fundus image or change the contrast or brightness, etc. So there's a lot of limitations there and leads to a lot of inefficiency. A slightly more updated approach is to use multiple applications on a review workstation. This is sort of the approach we used in our practice several years ago. And so essentially under this technique. You're basically using a different app for each device in which you obtain an image for that patient. So you end up pulling up a lot of different apps, having to log into each app and enter the patient info into each app. And it's a lot of redundancy, a lot of wasted keystrokes. Obviously, the upside, as opposed to paper printouts, is that you are able to interact with the images. They typically are of larger size. They're nice, large digital images on a computer monitor. So some benefits over printouts, but certainly still a limited way to review images. So at this point, I think really the gold standard for image review at this point is using a PACS system, which is really a comprehensive image review solution in which all the patient's images from all devices are stored in a single location and are reviewable and able to be interacted with within a certain software solution. In terms of PACS systems, I think the Zeiss integrated diagnostic imaging platform is certainly the foremost retina PACS on the market today, and that's what we'll be digging into further during the talk. The Zeiss IDI consists of two key components. There's the backbone, which is the form review software, which is basically your ophthalmic PACS, a fully featured image review system, and it has a add-on, the Retina Workplace, which is an advanced retinal analytics software. This is how the Zeiss IDI system infrastructure is set up in our practice. We obviously have many OCT and OCTA devices, as well as a plethora of fundus imaging devices. And these, I should note, are both Zeiss and non-Zeiss devices, although we predominantly have Zeiss devices. And these devices all capture images and create DICOM files, which then are transferred to our Forum server, which is our sort of single repository of our retinal images and helps manage all of our imaging data. The Forum server then communicates with all of our offices. We have a large practice in Middle Tennessee. We have a main office in Nashville with about 8 satellites scattered throughout Middle Tennessee. And within each of these offices, there are multiple lanes. In each lane, there's a review workstation running a Forum review and Retina Workplace. And that software communicates with this Forum server to allow us to review a patient's images, interact with them, annotate them, etc. This is sort of a decision that we made as a practice many years ago, that we really value the ability to have access to a patient's entire imaging history at any office at any time. And so what does that mean? Well, but let's say, for example, we have a patient who's typically seen at, say, Satellite 1. They go there monthly and get lots of images, and they call us one Saturday with a new urgent problem and are asked to come see us at our main office for a triage visit. And so when they come to our main office, we still have access to all those images from Satellite 1 and can compare the current day's images to the prior day's images. And we find that really lends itself to higher quality care, and it's something that we really value. Obviously, the specific structure for this setup can vary depending on practice needs and size, right? You could have a single workstation running a single iteration of a Forum review for a small single office practice. You could set up individual Forum servers at a couple of regional satellite offices just to review images in that site, or you could have this very large structure like we have, where we have this regional infrastructure to feed all of our satellite offices. Again, a very scalable application. So how does Forum review work in practice? Well, the initial screen that you'll encounter is this screen right here, and it's the patient directory, which acts initially as a database that's linked to your central server. With your standard search bar here, you can identify a patient by name or ID number. There's also advanced search options, which we can look at a little bit later. But basically, you would select the patient, you can double click, and this will bring you to the patient record, which is the screen we see here. This contains the patient's entire imaging history. Each of these rectangular boxes represents all the images obtained at a single visit. You see the date right here, and each thumbnail represents a different image, a modality, or a different repeat, I guess, image from that same modality. On the right, we have our visit history containing a selectable list of visits. This is basically the entirety of the patient's history of visits at our office. You'll notice these columns here, and these represent different imaging types, sort of grouped into broad categories. And so this is a good way to quickly identify, say, the last time the patient had a fundus photograph, right? You see there's one here on August 15th of 2018. You could scroll down, and the next pink dot represent the most recent prior fundus image. So again, a nice and quick way to identify, say, a similar image. You can also click on these headings and bring up only the visits that have that type of imaging done on that day. If you double click on one of these images, it brings you to this interactive image review page where a study can be reviewed, adjusted, annotated, et cetera, as needed. You'll see here we pulled up a 5-line raster scan, which shows your cross-sectional B scan here in the large pane, and then on the smaller pane to the right, you have your ENFAS fundus image demonstrating the location of the B scan that you're evaluating. You can switch these by double-clicking on the fundus image on the upper right and bring that to the larger pane. So again, just a pretty standard way to review images. I want to note that this interactive review can be done with both Zeiss and non-Zeiss devices. So I think that's a feature that's relatively unique to Forum. Device manufacturer agnostic. You don't have to only use Zeiss devices, and I think that really speaks to Zeiss's efforts to make this a all-in-one solution, so you don't have to have all these different softwares running in your practice. This is another way to review images in an interactive manner. We're looking at the fundus image review. We see here a patient who has geographic atrophy, which is sort of progressive over time. And I wanted to show this image because it kind of highlights how easy it is to do these comparative arrays. If you think back to our patient record page, you have those little thumbnails. If you highlight, say, 3 thumbnails from different visits, you can right-click and hit Document Display, and it brings in automatically this sort of comparative array. In this case, it's a 3x1, but you can change that up. It can also sort of automatically choose the kind of the best size. If you chose, say, 4, it'd be a 2x2, et cetera. But again, a nice way to review fundus images in a longitudinal fashion. But this, I think, is really where the Zeiss IDI system shines. It's this Retina Workplace feature, which is an advanced retinal analytics software package. This really allows you to dig more deeply into sort of macroscopic trends in a patient's OCT data over time. There are several powerful analyses that are available. There's this first one, which is the macular thickness analysis, which looks at different OCT thickness metrics over time, right? Things like central subfield thickness or cube volume. There's also the advanced RPE analysis, which looks at RPE density, or basically geographic atrophy development over time. And then there's the angiography analysis. And this is, I should note, in the newest version of Retina Workplace, which is still pending FDA approval, that's where this feature will be available. There's a sort of a skeletonized version of it currently in the current version of Retina Workplace, when you can look at the ENFAS images over time and sort of interact with them, but it's missing this sort of longitudinal aspect where you can look at all the data over time. So, but what the plan is, and I've had the opportunity to use this, is look at specific angiometrics, so things like FAZ size or vessel density, et cetera, over time. I think this is really going to change how we use OCT. I think one of the big limitations that we've encountered so far with OCT angiography is that it sort of lacks the quantitative data that we're used to using with macular thickness metrics like central subfield thickness. So once we get quantitative data, particularly comparative quantitative data, I think that's going to help us really unlock some information that we've been missing by just staring at these ENFAS images. And so I would look out for that in the near future. So this is what the standard Retina Workplace screen looks like. You get this sort of 3-up OCT comparison, which I think, again, is unique to this system. So most OCT review softwares that I've used have basically 2 panes, which is one for the current visit and one for the prior visit. And in this case, Zeiss has added a 3rd pane to pull up a 3rd OCT to be reviewed. Again, this is in point-to-point registered fashion, right? So as you scroll through these images, they all scroll together. So you're really comparing each slice to the prior visits slices. Again, two separate visits in the past. This is nice because you can use the sort of standard current and previous visit, and also have a 3rd box to look at, say, the patient's first visit or maybe their last recurrence for patients undergoing anti-VEGF therapy. Why is that helpful? Well, a couple of reasons. One, I oftentimes like to pull up the first visit because patients may, as in this case, see a pretty modest improvement or almost no change between the previous and current visit. But when you're able to show the patients or educate them, this is where you came from, you can really help encourage them that indeed we are making progress. Not every visit shows a tremendous jump, but just show them where they came from. Also, I like the ability to look at the last recurrence to see that, to make sure that we're not sort of trending in that direction and maybe adjust therapy as needed. On the bottom here, we have this longitudinal sort of line graph analysis. And what we're looking at here in orange is the central subfield thickness. And in green, we have our average cube thickness. And this is plotted over time. And each dot here represents a different visit, right? So we're not just looking at the 3 OCT or 3 visits that we have in the OCT comparison above, we're actually looking at all the patient's visits, again, over time. You have the dates down here on the bottom. And what's nice about this is you can actually click and drag one of these visits up, and it'll actually pull up the cross-sectional image as well as a thickness map in that box. So again, very easy to quickly look back. And as you can see, you can actually note little changes in the patient's status, right? So here was a little blip where they had an increased CST, so maybe a little recurrence here. Again, it's an easy way to go back and say, well, how did they look when they had their last recurrence, and what was the time frame at which they had that recurrence? So a nice way to help manage our patients over time. So at this point, it'd be nice to move on to some cases and actually pull up the software and really show you how it works. With this sort of live tutorial, hopefully you'll be able to get a feel for exactly how Forum and Retina Workplace can work to enhance your imaging process. I think before moving on, though, I do want to highlight sort of 2 different ways in which I'll be using the software to kind of maximize what we're able to obtain from our imaging. You'll see these during the tutorial, but I want to highlight them ahead of time so you know exactly what I'm talking about when I refer to these terms. And the first thing I do a lot with the software is I use these multimodal overlays, as we see on the left. And what this is basically all the patient's images sort of stacked on top of each other, right? So we're able to correlate locations and correlate different imaging modalities as well as cross-sectional imaging all on a single screen, right? It's very easy to navigate between these different imaging types with just a few clicks. I think this is very helpful for correlating and assessing findings across different modalities, which is a key for diagnosis. So I use this frequently in new patients or patients with new problems or unknowns. And the other aspect we just kind of touched on the previous slide, which is these longitudinal analyses, which is where Retina Workplace really comes in. And this helps us kind of monitor change over time. I think this is very helpful for disease management, particularly as relates to patients undergoing anti-VEGF therapy. So again, look out for these in the live tutorial because we'll be kind of talking about this quite a bit. So.
All right. Thank you, Eric, for that discussion. And really great to see all those features. You know, Forum has been around now for close to 6 years, 6 or 7 years, I believe, and it really has evolved a lot from the beginnings. Tell me about some of and for you watching the live program today, please feel free to ask questions. This is a live program, and we have certainly an expert in this device that's with us today. So, Eric, tell us a little bit about the compatibility of imaging devices across the field. So you showed some great images of OCT, but what about like Heidelberg OCT? What about some of the other manufacturers? How do they integrate with Forum?
Yes. So as I mentioned, the software is relatively manufacturer agnostic. So any device that can create a DICOM file works with Forum. So you could actually, I showed some of those 3-up OCT comparisons. You could pull up 3 consecutive Heidelberg OCTs and scroll through those, right? So it allows for interaction with those. At our practice, we certainly have lots of different device types. We have Optos cameras, we have Topcon cameras, we have a Heidelberg OCT, and a Heidelberg HRA, and those are all compatible with Forum. The one thing I'll mention, I showed this sort of longitudinal analyses, right? So they're actually plotting, specific metrics, whether it's OCT or RPE, density. Those metrics are specific to Zeiss device, right? So you can only do those longitudinal analyses on those for Zeiss devices, right? So it can't pull out a Heidelberg OCT and pull out the OCT. There's a lot of proprietary sort of information with each device manufacturer in terms of how those numbers are generated. And so that's the one limitation.
Mm-hmm. I love the idea of delving into all this data, but tell me about when it really makes a difference to you. So like somebody might say, well, I don't really need this because I can just look at a PDF report and look at the number today and last time and say it's different. How does that person, how would you discuss that with that person?
So I mean, like I said, obviously we all practice differently. And so, for some folks, maybe that's, adequate for, what they want to do. I think where it really makes a difference, and actually I would say that it saves time. I think people like paper, people like paper charts, people like paper printouts because they think it's fast and easy. But I think, oftentimes can be less efficient when you compare to having all this data at your fingertips. Like I said, I think that the key thing I like is being able to quickly sort of determine a patient's optimal sort of treatment interval. Patients undergoing anti-VEGF therapy by looking at their sort of longitudinal analysis. You can look at it very briefly. It's very easy to look back. Doing that with paper is a huge production. So I think that would be a key component. I think also, we used to have, we had a satellite clinic that was an hour and a half from Nashville, and we used to have only sort of paper printout capabilities there. And that clinic was incredibly slow because, if there was some problem with the printer, or if we had multiple images I wanted to print out, it took a long time to print those out. And so I think that really limits your efficiency. And so you say, oh, I'm happy with paper, sure. But I think if you tried a, sort of all-in-one solution like this, you'd notice that there's a huge time savings there. Not to mention, I think the improvement in the quality of care you could provide as well.
Yeah. Yeah. And talk to me more about that, because you mentioned this a little bit in your satellite offices. Do you have your referring doctors have this too, or does that referral network exist at all? And, or do you find that you just have to make less repetitive images? Have you actually looked at that benchmark as far as repetition of images, or what have you sort of found in that realm?
Unfortunately, most of our referring doctors have, I think, limited imaging capabilities. And so, it'd be great if everyone had, a single system that we could all share images. And certainly there's, issues there regarding HIPAA and, patient approval. And so at this point, we don't have that capability to share with referring providers. It would be, a great thing to look for in the future. So I'm not sure that it helps that much in terms of, limiting, the repetition of images. Certainly I think, going from our main office to our satellite office, that certainly, limits the repetition there, right? So if someone is seen by one of my partners in Nashville, and then they end up, following up in our Cookeville office an hour and a half away, I don't have to repeat, the FA because I don't have it with me, or I can't, find the paper printouts, et cetera. And so I think at least within our, larger practice, I think there's a lot of efficiency in terms of, limiting that in terms of repeating a different imaging, but certainly not from a referring provider situation like you mentioned.
Yeah. Yeah, we're fortunate to have it across all of our offices, and some of our optometrists will just take a picture and send it to me and say, hey, do you want to see this patient for surgery? And it makes it a lot easier just to book them on the phone rather than coming and seeing you, because you have all the imaging information you really need in front of you to do that.
Yeah.
So
I mean, that's fantastic. And obviously, you're in a multi-specialty group or in a large retina-only group. So I think that certainly, can play a role. What I do find is helpful for is that sometimes I want a sort of a second opinion from one of my partners, right? So there's an example where I can get a bunch of images, and, we have, a pediatric specialist in our group, and a UVI specialist and an oncology specialist. So I can get those images, at any of the satellites and say, hey, I just didn't know if someone needs to see you immediately. Is this something that I should just watch? And I could just call them up on the phone. They can pull them up in their office, and it's a pretty quick and easy way to get that second opinion. It kind of has that feeling of everyone being in the same place, even though we're spread throughout Middle Tennessee.
Mm-hmm. Yeah, that's great. Tell me a little bit about the COVID-19 pandemic and how it's impacted your practice, and maybe in more of focus on imaging and sort of focus on what changes you made in regards to that.
One of the big things, I think, at least obviously, there's 10 providers in our practice. And so I think we all approach things a little differently. One thing I've certainly relied on more is more OCT angiography as opposed to traditional angiography. I think simply from the fact that there's a lot less time spent face-to-face with the patient. There's a lot of contact. I mean, it's basically a contactless angiogram. So I think that's one easy switch that I've made. And I think, with the newer, Zeiss OCT, the Cirrus 6000, able to get 12 by 12 and 8 by 8, scans, and even montage of 6 by 6 and 8 by 8 scans. I don't really see the need for FA as much anymore. I mean, I think even before COVID, that was sort of the situation. The other thing that I've sort of switched to is that in order so that we have less people sort of crowded in a small exam lane, I've started reviewing all my images on a workstation outside of the review of the patient lane. So I can look at all their pictures, get my sort of sense of how they're doing, and maybe if it's a new patient, what the diagnosis is. And then I go into the patient, I sort of discuss those imaging findings with them. I can maybe pull up a few sort of key points if I want to show them, but I spend a lot less time in the room with the patient, because when I'm in there, it's me, the patient, a staff member. It's just a lot of people in a small, poorly ventilated room. So I think in general, I found it to be a really effective way to manage in the COVID-19 era.
Yeah, that's great. Question from Martine about the Plex Elite. Do you know how much of the Plex Elite integrates with Forum currently? Have you had any experience with that?
Yeah, so we don't have a Plex Elite. I'd love to have one. I think you guys have one in Cleveland. You could probably answer that better than I could. If you want to let me borrow yours, I'm happy to answer that question too.
he'll be on a truck with me coming to Nashville shortly. So,
Perfect.
you know, one of the things is I know that for the Plex Elite, you can get the PDF reports, but you're certainly correct. The raw data does take up a lot of storage, and so it's a consideration, and that's why it's pretty is not integrated in our forum environment right now. And we'll get to another question, I think, about multimodal overlay after cases, because I think you have some relevant cases to this discussion as well. So with that, we'll turn it back over to you, and you can cover the cases.
Great.
All right, let's jump into the live software tutorial. So now we have our first screen pulled up, which, as we saw on the slide deck, is the patient directory. Again, the standard search bar is here. You can search by patient name or ID number. There are several advanced search features. You can search by date of birth, visit date interval. You can search by the physician who performed the imaging or device type, even modality. So a lot of different ways to find the patient or image that you're looking for. So the first patient we're going to look at here is patient SC. This is a great example of the multimodal overlay technique I was mentioning at the end of the slide deck. So let's pull up patient SC here. You'll see over here on the visit dates here, this is a patient who originally saw us back in 2017. Unfortunately, was lost to follow-up for several years and was re-referred in July of this year for advanced diabetic retinopathy. So unfortunately, this patient got a lot worse during that interval when they were lost to follow-up. So you can see that this is a patient who we obtained a whole series of images on, and you'll see why in a little bit. But again, a lot of different imaging types. So let's pull up our first multimodal overlay. We're going to pull up the 8x8 HD OCTA scan, and you'll see that we have this overlaid on a Claris fundus photograph. So the first thing we're going to see is we have our large high definition OCTA scan here. Essentially, a great detail of this pretty extensive temporal non-perfusion here, just temporal to the macula. There's also focal areas of non-perfusion, kind of perifoveally, and then there's this large area of retinal neovascularization kind of extending from the optic nerve along the supratemporal arcade. You can look at the underlying image here with your optic nerve showing NVD, and here's your extensive NVD, some early fibrosis here. You can zoom in pretty readily and look at that, and then we can also look at our angiogram. Here's a kind of a mid-phase angiogram. You can see here, again, that same area of non-perfusion appears temporally. You can compare it to what we see on the OCTA, a very careful comparison. What's nice about these two modalities, traditional angiography and OCTA, is they provide sort of complementary information. Here with the OCTA, I think you get better vascular detail. These areas of perifoveal capillary dropout are a little easier to see on the OCTA. They kind of jump out at you, whereas on the FA, you have to really look carefully, and I think the OCTA really brings them out. The other difference is you see a lot of leakage from this neovascular complex here on the retinal surface. You can actually see the vascular detail much better on the OCT angiogram, which I think is a nice feature, again, how they're complementary. We can also look at a later phase angiogram here just by clicking. So again, you see how we get around all the different images just by a few clicks, and then we can use our overlays. Also, there's the cross-sectional data, which is here above, and we can highlight that by just double clicking and making that bringing it into the larger pane. And again, here's our cross-sectional data. Right now we have the OCTA flow overlay here, which is nice, but that can be distracting. So if you want to remove that, you can simply just hide that flow, and we can scroll through the cube. You see there's a central epiretinal membrane with a little bit of puckering here, but as we scroll superiorly, there's a more fully formed pre-retinal, more fibrotic membrane that causes a little early contraction, not a tractional detachment yet, but heading in that direction. So this can be, again, a nice way to correlate what the slice you're looking at with what you're seeing on the fundus. Also, if we wanted to bring back our flow data, you can see again how vascular that pre-retinal tissue is, right? So if you're thinking about doing surgery in this patient, you got to be aware of how vascular this is, because this is going to bleed quite a bit during surgery. So something just to be aware of. So a nice way to kind of review this patient. I want to also move over to the other eye. That was the right eye. Let's look at the left eye here. This eye is a little bit more advanced. You can see here similar extent of retinal neovascularization. with some fibrosis here in the central macula along the infratemporal arcade with some vitreous hemorrhage. This patient, unfortunately, probably needs surgery, right? The extent of fibrosis here makes me concerned for anti-VEGF therapy or a pan-retinal laser. I'm concerned about inducing some contraction, actually inducing a macular tractional detachment. But patients who need surgery sometimes like to get a lot of different cubes to look at different areas of the fibrovascular complex, again, to kind of establish surgical planes. And that's what I did in this patient, so I can show you how the overlays work in that situation. So here is our same photograph, and now we have our B-scan OCT data here. We can correlate, and so we can actually look and see, for instance, just temporal to this fibrovascular complex, the hyaloid's elevated, right? Obviously, one of the important steps in treating diabetic retinal or tractional detachments is you have to release anterior-posterior attachments to find areas where the hyaloid's elevated and sort of pierce or transect those and relieve attachments around the fibrovascular complex for 360 degrees. That'll help prevent peripheral breaks. And so this is a nice way to establish where the hyaloid is elevated. Also, if we scroll superiorly, we see areas where you can start to undermine this fibrotic tissue. See, there's a surgical plane there. A great way to start your delamination and remove this area of traction. So again, a nice way for surgical planning. I kind of did these little cubes throughout the macula, and you'll see that here. Let me scroll here again. You'll start to see some more planes developing here where you can undermine this and lift off this fibrovascular tissue and really help this patient's vision. So a nice way to use this multimodal overlay, both for initial diagnosis as well as surgical management. So I think that's a nice technique. So that's patient SC. Let's move on to a patient with a different disease. This is patient BW. It's actually a patient who originally saw one of my partners back in February of 2016. I'm going to show the fundus photographs here first. And so what we see here is some metalliform-like debris here in the central macula, kind of in a pseudohypopian appearance with some RPE changes. Also, if you look carefully at the optic nerve, you'll see that there is this reddish sort of concentric ring around the optic nerve with some radial extensions in both eyes. And so what those are, as I'm sure everyone's aware, is angioid streaks. This is a patient who has angioid streaks with the associated vitelliform dystrophy. And so my partner evaluated them, looked at the OCT, noted this sort of hyporeflective space with this sort of subretinal hyporeflective material, which is the vitelliform debris. It's true in both eyes. A little bit more that subretinal hyporeflective material in the left eye. With that hyporeflective space. This looks sort of like degenerating vitelliform lesions in both eyes. This patient was recommended to pursue observation and no treatment was provided. However, that patient did return to see me about 4 months later and had complaints of progressive metamorphopsia in the right eye only. And so at this point, I actually obtained an OCT angiogram. I'm going to pull that up and we're going to have another nice multimodal overlay to review. And so there's that actually the original fundus photograph from the prior visit, and you can see again that the vitelliform type debris. If you look at that, this is actually the current OCT from the visit when I saw them. So there's a little less of that subretinal hyporeflective material, and maybe that hyporeflective cavity is a little bit larger, but hard to say that's subretinal fluid based on the prior images. We can review the FA. This is actually the red free, which kind of highlights those angioid streaks. And then here's kind of the early FA, which you see this area of hyperfluorescence in the surrounding or sort of in the area of those angioid streaks. That's the kind of early, and then here's a kind of a mid phase, and you don't see much leakage anywhere. You see just kind of hyperfluorescence along the area of the angioid streaks. However, if we pull up the OCT overlay, you see a very obvious CNV here in the sort of infranasal parafoveal region. And so if you look carefully at the FA, actually it really makes that lesion pop, even though it wasn't leaking, but it was hard to see that in the absence of the OCT angiogram. So again, our overlay, or sort of the OCT overlay, is complementing what we have on fluorescein to really make those findings stand out. So I think that's a really helpful way to review. So this patient actually ended up initiating anti-VEGF therapy in the right eye only, with improvement in their symptoms, and this hyporeflective cavity did get smaller, but didn't completely reduced to nothing because there was still this degenerating vitelliform portion. And you can actually compare it to the other eye. You can see that the other eye does not have any evidence of CNV, and this eye was just observed. So again, a nice way to show the complementary nature of traditional angiography and OCTA. And now we can move on to patient HJ, our final multimodal overlay example. I'm going to pull up their images, and this is a patient who was referred for, oops, I want this one instead. Was referred for a retinal tear in the left eye, and we can take a look here at our wide field Claris photograph. You see there's this kind of large, what looks like a tear supratemporally, but if you actually examine this patient in clinic, you see there's a schisis cavity in this area, and there's this kind of scrolled tissue under the schisis cavity. So this actually looked like a area of schisis with a large outer retinal break. But you want to confirm that finding. This is someone who maybe, if it's just an outer retinal break, you could observe very carefully or just laser this region. But if it's a true schisis detachment, the patient will probably need surgery because that's a fairly progressive issue. And so what we did was got a peripheral OCT. And I find this technique very helpful because when you get peripheral OCTs, the cross-sectional information is helpful, but you don't necessarily always know where on the fundus you're looking. And so it's very disorienting if you instead of having this under overlay, you had this, just this gray box here. You would have a very difficult time knowing what you were examining. And so why don't we look at the cross-sectional image. So again, we're seeing at the apex here of this lesion, it's kind of this scrolled outer retinal tissue, but here's your inner leaflet, right, the schisis leaflet, which looks pretty much intact. But as you scroll inferiorly, you start to see oops, there's a defect there, and now there's going to be another defect here. So this is actually a patient who has a schisis detachment because they have breaks in the inner leaflet as well as a large outer retinal break. And so this patient actually needed surgery, but you confirm this with the imaging and again, the correlation of the fundus photograph and the OCT B scan, very, very helpful. Like I said, if you had just this instead to look at, you just really wouldn't know what part of the retina you're actually examining. So I find that very helpful. So that's patient HJ, again, a multimodal overlay with assisting placement or localization of a peripheral OCT scan. So let's move on next to some of our longitudinal analyses examples. Our first patient is going to be patient DH. You can see this is a patient who's been in our practice for about a year and a half. First seen in December of 2018. Oops, we're going to pull up the macular thickness analysis first, and you'll see again our 3-up OCT comparison, which we reviewed in the slide deck. You have your thickness maps on top with your point-to-point registered OCTs in the bottom. Again, as you scroll through, you see these all scroll together because they're point-to-point registered. If you want to look at those larger, you can just click this button down here, which brings the images in greater detail and removing that longitudinal analysis graph. But I do want to show some other ways to look at the ENFOS fundus image. You have some other overlays. You can look at your ETDRS subfields. If that's something you're familiar with or prefer. Again, you have some quantitative data there. You can also look at various ENFOS labs if for whatever reason you wanted to look at the, say, vitreoretinal interface OCT ENFOS. The other thing I do like is there's this minimum intensity overlay, and what this is showing is the area of lowest reflectivity within this slab, which is basically the entire retinal thickness in ENFOS fashion. You see there's, back in May, there was a big recurrence here, so a lot of CME, you see all of that area of CME here. But even when there's less or almost no CME, it's going to be helpful because they help you identify areas where there's still some residual pockets of fluids. If we scroll up here to that little black area on the minimum intensity map, you can actually double click to make anyone bigger here. So I'll double click. You can see there's a cyst right in that area. And then we scroll through there, see there's a little area of CME there. And that's nice because it points those areas out. You want to look at them a little more closely as opposed to having to carefully and tediously scroll through the whole the whole cube. You can quickly identify some areas of residual fluid. So that's a helpful way to use that minimum intensity map. So some other things you can do, there's a quick button here for looking at sort of your basic thickness metrics, visit to visit here. So this is central subfield thickness, cube volume, average cube thickness. You can also look at the volume or average thickness within the ETR subfield. So again, if you're someone who really likes these quantitative numbers and to have in sort of a quick reference, that's another way to look at it. What I tend to use is this line graph, which we looked at in the slide deck, which is showing on a visit-to-visit basis changes in these specific metrics we're looking at. I chose central subfield here in orange. There's average Q thickness here in green. I said there are several other options: Q volume, various ETR subfields. You can look at RPE elevations. So there's a lot of different things to look at, but here in this case, we're just looking at these two parameters. And this might help explain why this patient had this recurrence that we see at their May visit, right? So each dot, as I mentioned, is a visit, and the distance between these dots is the time between visits, in this case, injections. And so you see this patient had this prolonged time between injections before the May visit and had a recurrence of cystoid macular edema. We've actually went ahead and annotated these visits. So each little injection symbol here in blue is an Eylea injection. Each one in green is a Lucentis injection. So you can see that when the patient went about 6.5 weeks here, they had a recurrence. And you notice that dates are April to kind of mid-May of this year. And so we had, unfortunately, many patients who fell into this boat due to issues with the COVID-19 pandemic and difficulty in getting patients in to be seen, and or patients having concern about coming regarding safety. And so we had a lot of patients who had some recurrences like this during this time frame. But if you want to look back further in their history, we can also find some more information about this patient. So, you know, we see the patient was switched from Lucentis to Eylea, and the question is, why was that? Well, if you look back here, there were a couple of recurrences here and here. Actually, pull one of those up if you'd like. You can just click and drag there and pull that up, and you see they had a recurrence back here in July of 2019, that was because this patient was extended beyond about 4 weeks. They did fine at 4 weeks on Lucentis, but anytime they were like here or here, just past 4 weeks, so 5-ish weeks, they had a recurrence. They were switched to Eylea. You see here, this is actually about a 5-week visit, and they did fine at sort of a 5 to 6 week interval on Eylea, but when they went about 6.5 and they had a recurrence. So this is a great way to sort of find or determine an optimal treatment interval. It's also, I think, helpful when you're seeing other people's patients, right? We sometimes see our partner's patients, and you're wondering, well, what's the appropriate interval for this patient, and why are they at this time frame? You can quickly pull this up and see that where they've had recurrences and where their best interval is if we're keeping their maculas as dry as possible. So I think that's a really nice analysis to use, and I think very helpful. So something I use in my practice every day. So that's patient DH. Let's move on to our next patient here. This is going to be patient HA, and this is another patient that I've seen for quite some time, and she has a history of a choroidal neovascular membrane in the left eye due to histoplasmosis. And let's pull up her scans. Fine, there's different OCTA scan sizes. I'm going to try to look at the 3x3s here, and I want to actually look at her first visit OCTA because it's a little more interesting. So we're going to just click and drag that up there. So we'll pull that up. And she has a CNV, so we're going to look at the outer retinal choroid capillaris slab. And so we made that quite large. And so this is her first visit in March of 2016. Again, this is the left eye. She has this large temporal parafoveal net here, or choroidal neovascular membrane. It's a type 2 lesion. You can see the flow here just above the RPE. So she underwent monthly therapy just for a short period of time. It was extended pretty quickly out to 12 weeks. Unfortunately, she was lost to follow-up for about 6 months. I think she thought she was doing pretty well and returned here in August of 2018. You see, again, she had subretinal fluid initially. That dried up. Well, now she has recurrent subretinal fluid with new symptoms. That's why she returned. Interesting, though, when you look at her OCTA, you see that this temporal parafoveal net is pretty well regressed still, but now she has this new distinct lesion in the superior parafoveal region, right? So you can see the flow here right here, and not much flow in this lesion over here. And so again, this is the source of the new fluid. So I think it's a nice way to highlight, you're really learning more about your patients When you look at them in this way, if you had just gotten a single OCTA, you'd say, oh, they have these little nets around. But again, this is different. And then when this patient had this repeat injection or reinitiation of their anti-VEGF therapy, even after just a single injection, this is actually August to September 2018, that superior lesion regressed pretty rapidly, and there's actually total resolution of the subretinal fluid in the subfoveal space. So I apologize, this looks a little grainy. I'm actually pulling the software up remotely. So as I scroll through here, there's a little bit of delay or lag, and that's from the internet, not from the software. So anyways, that's patient HA. You have one more patient I want to highlight here, and this is patient JW. So we'll pull them up here, and this is a patient, as you can see here, who has pretty advanced geographic atrophy. This is going to be a great example of using the advanced RPE analysis. So you can see here, we've seen this patient for many years now. They actually were first seen in September of 2009, and we have images all the way to January of 2018. And so in the ENFOS OCT image here, our fundus image, we see outlined in yellow is the area of RPE loss or geographic atrophy. You see that's non-central. The distance to the fovea here is measured by that red line. 5 years later, we see a pretty pronounced increase in the area of geographic atrophy encroaching now on the fovea. And then by January of 2018, complete wipeout of the central macula, which is unfortunate. And what's nice is we've actually plotted this over time, right? So we, in green, have the illumination in that central 5 millimeter circle, which is basically the extent of the geographic atrophy lesion size. You see that's increasing over time. And then this orange line is the distance to the fovea, and see that decreases over time. So somewhere between September 2014 and January 2018, this lesion went subfoveal, and obviously the patient's vision was affected by that event. So that's a nice way to track this over time. Why is this important? You know, you would say we don't treat geographic atrophy. Well, at least at our practice, we're involved in a lot of clinical trials for therapeutics for geographic atrophy. And this is a great tool for me to show patients sort of how rapidly they're progressing. That oftentimes influences their decision on whether they'd like to participate, either to help themselves or help someone in the future. And so you can pull this up and say, well, here's the rate really at which you're worsening. And you know, this is the expected outcome. And so I think that can be helpful. And I think this will be a really useful tool once we do have an FDA-approved therapeutic for geographic atrophy. So again, I plan on using this a lot more in the future. Just to show you that this is also multimodal as well. You can look at that was the fundus image, but you can look at the patient that had autofluorescence images done at these visits as well. So you can pull those up. You know, I don't have the fundus photos for this patient for those visits, but you could have looked at those. Here's the fundus image from the OCT. So again, not only is it longitudinal, but it's simultaneously multimodal. So that's sort of a brief tutorial in a nutshell, really just a high-level overview of how form review and retina workplace function, particularly as relates to the use of those multimodal overlays for diagnosis and surgical planning and exploration of unknowns, as well as the use of longitudinal analysis for ongoing management of retinal disease, particularly in those patients who are undergoing anti-VEGF therapy. I think both of these review techniques leverage the strength of the IDI system, which is the ability to correlate images from different modalities, again, all in a point-to-point registered fashion. You know, simply by clicking on an image, you can bring yourself to the same location in a different image type, and I think get some additional information. And it's further enhanced by the precise correlation of the associated cross-sectional OCT data when you get both types of imaging for an individual patient. I probably didn't emphasize this enough during the talk, but this software is also incredibly useful for educating patients. Having all those images in a single location, able to be reviewed in a rapid fashion, I think really improves their understanding of the disease and helps them understand that these images aren't all separate. This is all the same retina, just looked at in different ways. And the saying is obviously that a picture is worth 1,000 words. And I think that's incredibly true with this software and can really help save you from a lot of unnecessary discussion and improve your patient understanding of their own disease. So at this point, I think I would stop and we'll move on to the Q&A portion with Rishi. I will look forward to interacting with you all and hopefully answering any questions you may have, and just want to thank everyone for their attention.
Great. Thanks, Eric, for the presentation. Really covered the question about the multimodal overlay. Eric, you walked us through some cases where you did it. Let's talk about chair time for multimodal overlay. Is it more chair time for the patient, or how does it work for that?
Well, I think it's certainly less chair time for the patient. You know, like I said, I think the comparison, as I had mentioned in the earlier slide deck, is, you know, pulling up 3 or 4 different softwares for different devices and having to, you know, log into each one and, you know, pull up that patient's information for each one. And so I think having it all on one screen allows you really to quickly, you know, pull up the different images. And then again, I think also it helps the patient understand sort of what they're looking at and how those images correlate much more quickly. So there's a lot less discussion about, oh, wait, well, I don't understand. You know, this other photo showed this, but this one shows something different. And you're trying to explain to them, well, it's actually the same retina, just looked at in a different way. And so I think that really cuts down on chair time, both from, you know, reduced clicks on the computer screen, but also reduced discussion, you know, easier understanding for the patient.
Mm-hmm. How about you showed the devices. Does it always have to be Zeiss devices for the overlay, or is it possible to mix together an Optos image with an OCT?
Yeah, so actually some of the overlays I showed were Zeiss Cirrus OCTs overlaid on other fundus cameras. And so I think some of the earlier ones, the gentleman with the vitelliform dystrophy, that was actually a Topcon camera image, as was the FA. The reverse, though, isn't true. So you can't use, like, say, a Heidelberg or another manufacturer's OCT and overlay those on other fundus images. And so that's a limitation, again, I think, due to some of the proprietary specifications of the different devices.
Walk me through some of the utility of the OCTA now embedded within that. So first of all, how do you access that OCTA viewing capability? And secondarily, what cases have you found it particularly beneficial in what disease states?
Yeah, so in terms of how you access it, so you actually just literally double click on the little thumbnail of the OCTA study that you want to pull up, and then there's a little, on the upper right, there's a little box, a little plus sign, and that allows you to choose any of your fundus images that you want to overlay that on. You can choose multiple, as we showed in some of the cases there, and that will just automatically register those. There is an option to manually register for whatever reason. It's not register where you want it, but typically it's pretty efficient just to select the image and have it automatically register. In terms of what I find it most useful for, I think for the fundus overlay, I really like looking at sort of retinal vascular disease. So when you're looking at sort of wider field OCTAs, it's really nice to know, well, where on the fundus am I talking about? It's really helpful to know. You can see because again, with an OCTA, you're only looking at flow, right? There's no other structures there, and so then that you can correlate that with sort of non-vascular structures. Looking at diabetics or patients with RVOs, I think can be particularly helpful. Peripheral CNVs again can be difficult to image and make sure that you in the right area. So those are sort of the key parts. I think for looking at choroidal neovascular membranes and AMD or other causes of CNV, I'm not sure that the fundus overlay is as important. It's certainly a cool feature, but you're just taking an OCTA of the macula, and that's pretty easy to know where you're looking in that situation. So I think the cross-sectional imaging can also be pretty helpful for determining where you are on the fundus.
Yeah. You showed some cases where you did a peripheral OCT. I was really impressed by that because it really helps you differentiate those cases of, for example, macular schisis from retinal detachment. Can you tell the people watching, how do you get good peripheral OCTs if there's a way to do so?
Yeah, it's obviously it takes a little bit of experience from the photographers, but really you're just having the patient fixate in a separate location. There is a target for the patient to look at, and that can allow them to sort of direct their gaze in a certain location. And so I think that's something that, with a little practice, most photographers, take to pretty readily. We have, probably, upwards of 12 photographers in our office. And like I said, I think pretty much all of them at this point can do pretty accurate peripheral OCT. And so, again, I think, in terms of like specific pearls, I don't get the images, but like I said, just by a little bit of experience, photographers are able to get that pretty readily. So.
Great. We talked about the fact that these devices have gotten faster from the standpoint of scanning capabilities. Do you feel like as a diagnostic criteria, you feel like you're faster or more reliable with some of these modalities now, these image data software modalities now than you were in paper, for example?
Well, I mean, I think, the big differentiating factor there is, can you sort of interact with the images or not? I think particularly for, looking at cross-sectional imaging in OCT, and there actually are papers published about, the accuracy of looking at, specific paper printouts of a certain number of, scans, whether it's a 5-line or I think it actually came out of Cleveland Clinic, actually, to be honest. You can look at it vertical or horizontal. And like I said, certainly there's a higher sensitivity for finding, fluid scrolling through the entire cube volume, as opposed to looking even at, say a 5-line sort of cross scan. And so I think that's a big point in the accuracy. I think also, talking more about, what Conform can do. I mean, I think, I thought that the great example that we just showed in the cases was that, schisis related detachment. That's something that, I may have, watched probably inappropriately had I not had that imaging capabilities. And like I said, it's very difficult. That's the one thing where I probably got a lot less peripheral OCT when I didn't have the overlay capability, because I just didn't know where I was looking, right? The accompanying fundus image isn't particularly helpful for determining where you are in the fundus. And so I think, again, that's something that's, a critical a factor in determining what is going on with this patient and what's the appropriate management. And so I think that's another situation where the software can really impact your accuracy of your decision making. In terms of speed, I think speed of the devices itself is great. I mean, particularly with OCT, I think it just allows you to get higher resolution images, right? I mean, the key about speed, isn't just that it, get your patients through faster. It's that you can image the patients sort of more comprehensively. You can get wider scans, you can get higher resolution scans. And I think you find details that maybe you missed, with an older generation OCT. I mean, I think the classic example is, looking at Plaquenil or hydroxychloroquine toxicity. I mean, those are pretty, minute changes that sort of can alert you to this patient starting to develop toxicity. And so I think the faster we scan and the more densely we can scan, I think the quicker we can find these patients and identify them and can more accurately sort of diagnose their problem.
Hmm. Eric, you showed that ability to mark the interval of a drug or the time of treatment. Tell people at home why that's important to do.
Yeah, so I really rely on the Form software to help me, again, determine sort of the optimal treatment interval. And so, again, if you actually look at, there's this whole host of papers on, switching from one drug to another. And, I think that certainly there's a lot of controversy as to whether or not there's actually a benefit to that. But, I think obviously we're treating patients as individuals and not as, some giant population. So if you want to know, did a patient do better after a switch, if you can mark, when they were receiving a specific drug and then switch to another, you can look, kind of take a step back and look sort of macroscopically and look at these various thickness metrics and say, well, actually they are getting better or actually aren't. I have another case that I have shown on some previous talks where, actually I started treating a patient every 2 weeks. And I was like, wow, they did great after I switched them from monthly to every 2 weeks. And if you actually just look at a small section of that longitudinal analysis, it looks like, yeah, they had a really high CST and it, sort of rapidly reduced. But if you actually scroll back out, you see this patient had sort of regular, almost sinusoidal, variations in their CST where they were getting worse just spontaneously and then would get better, again, just continuing monthly therapy. And so that's a situation where I thought I was, sort of impacting that patient's care when they had sort of had this regular pattern of worsening and then improvement. And that's something you can only really see on this, broader longitudinal view. I'm not going to go through every OCT of a patient's had in every visit. It's not reasonable. Certainly, I don't have that kind of time in clinic to do that. And so this allows you to really get that sort of information in a very quick and accessible manner.
Mm-hmm. Go ahead and tell me what you would wish for in the software, be different or better.
Yeah, I mean, to sort of tag on what we were just talking about, I mean, I think a really nice feature in terms of wish list would be EMR integration. So, the ability for that, longitudinal plot to be filled out by my EMR and say they got this drug on this date would be fantastic. And also the reverse, the Form could input into my EMR what those various thickness metrics were, automatically without my staff having to say, look up on Form and say the CST was, 350 and they put it in the EMR. If there was crosstalk there, I mean, I think that would be a huge efficiency savings. And I think also When we're really still in this anti-VEGF era, when that's really primarily what we do, I think, being able to know what drug they received and what that interval was between each injection and correlate that with the thickness metrics would be really high on my wish list. I did show the angioanalysis, the angiography analysis, the angiometrics. That certainly is coming. I think it's on my wish list, but I've actually been able to use that a little bit with a newer generation of form, which is not yet FDA approved. But I think that's really going to be a big boon to us, just having a quantitative number. I mean, I think OCTA is nice to look at, particularly when you're looking at, sort of retinovascular diseases and looking at, the inner retinal flow. But if we could put a number to it, we're more comfortable with that. We're used to things like CSDs and cube volumes. We need something similar for OCTA, and having that ability to look at those over time, I think will hopefully help change management. Another thing, I guess, I sort of look at a form as sort of a future-proof, setup, in the sense that I think it'd be very easy to plug in like an AI setup, right, or AI integration, with form. The data is all sitting there, and so once AI algorithms are at the point where they can maybe tell me stuff on my patients that I just haven't been able to figure out, you could just plop that on top, sort of a software add-on. I think we'd be able to really churn out some interesting information and maybe some greater insights about our patients that, again, a simple human brain just can't comprehend.
Yeah, I would agree with you. I think one of the big things could be the integration of an AI piece, which I know that Zeiss is working with us on in Cleveland in our research lab, where you can actually pick up B scans of interest. And I think the data on fluid fluctuation is really imperative and important. We probably need some sort of way of capturing that, how you said, the amplitude of that fluctuation, what that means. So thanks, Eric, for those wonderful cases in the presentation. And thank you for all watching. This is the third of the third series. So thanks again for joining us tonight.
Thank you.